Welcome to Cosmic Voyages, where we take you beyond the stars, diving into the most captivating mysteries of our cosmos. In this episode, we're going to discuss a shocking revelation that has rocked the astronomical community. Pluto, the enigmatic dwarf planet that was once a part of our solar system's family, is now back in the spotlight. But this time, it's not about whether it's a planet or not. It's something far more urgent. Could Pluto be on a collision course with Neptune? Two of the most renowned astrophysicists, Neil deGrasse Tyson and Michio Kaku, have raised alarm bells about this potential cosmic catastrophe, and the consequences could extend far beyond these distant worlds. In fact, they may even reach Earth. How is such a collision possible? And more importantly, what could it mean for the solar system and life on Earth? Let's unravel the intricate mechanics behind this rare astronomical phenomenon and see if a Pluto-Neptune impact is really looming on the horizon, or if there's more to this story than meets the eye. To understand how we arrived at this extraordinary prediction, let's take a closer look at Pluto's unique characteristics. Pluto, discovered in 1930 and demoted to a dwarf planet in 2006, has always intrigued astronomers due to its bizarre orbit. Unlike most planets that follow relatively circular paths around the Sun, Pluto's orbit is highly elliptical, meaning it stretches out in a long, egg-like shape rather than a near-perfect circle. On top of that, its orbit is tilted at an angle of 17 degrees to the plane of the solar system, which makes it much more unpredictable and, in some ways, more dangerous. Pluto takes an astonishing 248 Earth years to complete just one orbit around the Sun. To put that into perspective, since its discovery in 1930, Pluto hasn't even completed one full revolution yet. For about 20 years of each orbit, Pluto actually comes closer to the Sun than Neptune, despite its far greater average distance. This begs the question, why haven't Pluto and Neptune collided already? After all, their paths intersect, and it seems almost inevitable that one day they could cross paths in a disastrous way. Yet despite their orbital overlap, these two distant worlds have managed to avoid catastrophe, for now. The reason for this avoidance lies in a fascinating cosmic balancing act. For every 3 orbits that Neptune completes around the Sun, Pluto completes exactly 2. This orbital resonance keeps them in sync in such a way that Pluto never comes too close to Neptune. Even when their orbits seem to intersect, Pluto is either far above or below Neptune's path, thanks to the dwarf planet's steeply inclined orbit. But could this gravitational dance, which has kept them apart for so long, break down in the future? This is where the alarm raised by Tyson and Kaku comes into play. The intricate gravitational forces at work in the solar system are far more complex than they seem at first glance. The so-called three-body problem, which describes how 3 objects in space, like Pluto, Neptune, and the Sun, affect each other through their gravitational interactions, reveals the delicate balance that exists between celestial bodies. Small changes in the position or velocity of any one of these objects can lead to massive shifts in their future paths. This makes predicting their orbits over long timescales an incredibly difficult task. Even a slight deviation in Pluto's orbit could send it careening into Neptune's path, with potentially devastating consequences. At the heart of this problem are several key concepts in orbital mechanics: azimuthal libration, latitude libration, and the von Zeipel-Coze oscillation, also known as the VZK oscillation. These terms might sound complicated, but they help explain why Pluto and Neptune haven't collided yet. Azimuthal libration refers to the oscillation of Pluto's orbit in such a way that whenever it crosses Neptune's orbit, it's positioned at least 90 degrees away from Neptune. This spatial separation is critical for avoiding a collision. Latitude libration, on the other hand, describes the vertical movement of Pluto as it orbits the Sun. This means that even when Pluto comes closest to Neptune in its orbit, it's typically far above or below Neptune's orbital plane, which provides another layer of protection. Lastly, the VZK oscillation, named after 3 scientists who studied how celestial bodies move under the influence of gravity, adds a final piece to the puzzle. This oscillation helps explain why, despite Pluto's chaotic orbit, it remains stable over extremely long periods of time. But here's where things get tricky. Despite these mechanisms keeping Pluto and Neptune apart, astrophysicists have long known that Pluto's orbit is technically chaotic. Even though its orbit appears stable over short timescales, tiny changes in its initial conditions, such as its position or velocity, can lead to wildly different outcomes over millions or even billions of years. In other words, while Pluto and Neptune are safe from each other now, the long-term future is far more uncertain. This is what Tyson and Kaku are concerned about. Could the chaos in Pluto's orbit eventually overcome the forces keeping it in check? If so, it's possible that Pluto could drift too close to Neptune, triggering a collision that would have far-reaching consequences, not just for the outer solar system, but potentially for Earth as well. A collision between Pluto and Neptune would be a cataclysmic event. Pluto, being much smaller and composed primarily of ice, would likely shatter upon impact, sending vast amounts of debris flying across the solar system. Some of this debris could even be flung into the inner solar system, where it could pose a danger to other planets, including Earth. Even if no debris reaches us, the gravitational ripples from such a massive impact could potentially disturb the orbits of other planets, leading to unforeseen consequences for the stability of the solar system. Tyson has expressed concern that even though the three-body problem has kept Pluto and Neptune apart for now, it's possible that the gravitational interactions between the two planets could eventually destabilize their orbits. And if that happens, the results could be devastating. He warns that the consequences of such an event would go beyond just the destruction of two planets. It could alter the balance of the entire solar system. Michio Kaku shares similar concerns, but he approaches the issue from a different angle. As a theoretical physicist and one of the leading voices in string theory, Kaku is interested in how extreme cosmic events like a Pluto-Neptune collision could provide valuable insights into the fundamental laws of the universe. The collision would release a tremendous amount of energy, potentially creating conditions similar to those seen in the early universe. This could allow scientists to observe phenomena predicted by string theory and other advanced models of physics in ways that have never been possible before. The gravitational waves produced by such a collision could also provide a unique opportunity to study the nature of space-time itself, offering new clues about how the universe operates on its most basic level. But what would all of this mean for us here on Earth? Fortunately, the immediate impact on our planet would likely be minimal. Pluto and Neptune are both incredibly far from the inner solar system, and even a collision between them wouldn't pose a direct threat to Earth. However, the indirect effects, such as shifts in the orbits of other planets or the potential for debris to be flung into the inner solar system, are harder to predict. And even if Earth isn't directly affected, the scientific implications of such a collision would be profound. The idea of planets colliding may seem far-fetched, but it's not entirely without precedent. Astronomers believe that early in the solar system's history, collisions between planets and other large celestial bodies were relatively common. In fact, it's thought that Earth's own moon was formed when a Mars-sized body slammed into the early Earth, ejecting enough material into space to form a satellite. More recently, in 1994, fragments of the comet Shoemaker-Levy 9 collided with Jupiter, creating massive fireballs visible from Earth. These events serve as a reminder that, while collisions between planets are rare, they're not impossible, and it's not just Pluto and Neptune that we have to worry about. Rogue planets, planets that have been ejected from their original star systems and now drift through space, pose another potential threat. These planets, untethered by the gravitational pull of a star, could wander into our solar system at any time, potentially colliding with one of the planets or moons. While the odds of such an event are extremely low, the sheer vastness of space means that we can never entirely rule out the possibility. In the grand scheme of things, the study of Pluto's orbit and the potential for a collision with Neptune is just one part of a much larger effort to understand the dynamics of planetary systems. The same gravitational forces that keep Pluto and Neptune apart also govern the movements of other planets, both in our solar system and in distant star systems. Understanding these forces is crucial not just for predicting potential collisions, but also for learning how planets form, evolve, and interact with each other over time. Theories about the late heavy bombardment, a period of increased comet and asteroid collisions in the early solar system, suggest that gravitational disturbances from the outer planets played a key role in shaping the solar system as we know it today. These disturbances, caused by the migration of the gas giants, sent a wave of smaller bodies hurtling into the inner solar system, where they bombarded the terrestrial planets, including Earth. This period of chaos may have been responsible for delivering water and organic materials to Earth, setting the stage for the development of life. As stars evolve and lose mass, the orbits of their planets can expand or contract, potentially leading to collisions or other dramatic changes in the system's structure. This is what scientists believe may eventually happen in our own solar system. As the sun grows larger and eventually sheds its outer layers, becoming a white dwarf. While the prospect of a Pluto-Neptune collision may seem distant, it's a reminder that the universe is constantly evolving. Gravitational forces shape the movements of planets, stars, and galaxies, and while these changes often occur over millions or billions of years, they can have profound consequences when they finally take place. By studying the dynamics of these interactions, we not only learn more about our own solar system, but also gain insights into the fundamental laws of physics that govern the cosmos. The truth is, space is a place of unimaginable beauty and awe, but it is also one of chaos and destruction. Yet it's this very chaos that fuels the creation and transformation of everything in the universe, including us. Whether or not Pluto and Neptune ever collide, their cosmic dance will continue to fascinate and challenge astronomers for generations to come. Thank you for joining us on this journey beyond the stars. Stay tuned for more as we continue to unravel the mysteries of the universe. Until next time, keep looking up.